Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, dear delegates and guests, my name is Mohammed Al-Jaradin. I speak to you from Sweden, where I have been living for the last 10 years. I'm happy to be with you in this conference. I hope I've been able to be physically in Sahar, but unfortunately I couldn't. So I'm happy to be with you today, and I wish you a very successful conference. So let's start.
This presentation is about our article entitled Adsorption of Organic Contaminant by Fly Ash in a Multiple Solute System. The article is part of several studies actually that have been conducted to determine the beneficial use of fly ash. The author contributed to the work are Dr. Kashki, and he also this work was part of his PhD work. Dr. Serkant, both Dr. Serkant and Kashki work at Veolia Water Technology Company, and also Prof. Tabas from St. Martin University in the United States, and myself, Mohammed Al-Jaradin from Lund University in Sweden. As we know that many industries still use coal to produce energy. So the combustion of coal produces a large portion of mineral matters, which is transformed into bottom ash and fly ash. Approximately 80% of the solid waste derived from the combustion of coal is fly ash, in fact. So the increased reliance on coal combustion will result in significant future fly ash storage and, of course, disposal problems. So in history, the simplest answer to this problem was to just send it to landfills. And to a great extent, this is still the common practice in many countries in the world. But as landfill sites are becoming rare and more expensive to operate and maintain, beneficial use of this inexpensive material are becoming more desirable and practical, in fact. So, what is the rationale behind this study? Actually, many studies have been conducted to determine the beneficial use of fly ash. And a good examples on that, the fly ash was used to remove heavy metals and the fluoride ion from petroleum sludge leachate. Also used as a sorbent for removing various heavy metals from aqueous solutions. And fly ash has a significant capacity for absorption of organic compounds from aqueous solutions. And also it was proven to remove organic contaminant from diluted solution containing a single solute. However, little investigation have been conducted to determine the absorption behavior of fly ash in a multiple solution system. This was the reason for this article, actually. To conduct our experimental work on fly ash, we brought fly ash from the electrical power generation station, which is owned by Electricity and Gas Company of New Jersey. This company is using bituminous coal, which comes from the eastern United States coal mines. And the coal and the fly ash was within 0.5 to 100 micron, and the service area was 1 to 6 square meter per gram. The major components of fly ash are ammonia, silica, iron oxide, calcium oxide, and residual carbon. So the exact chemical composition of a fly ash is controlled by the characteristic of the coal itself and the combustion temperature and also the boiler efficiency. So to determine the absorption behavior of fly ash in the presence of organic solutes from different functional groups, we have prepared 3 mixtures as you see in the slides. These mixtures have polar compounds, butanol and methyl isobutyl ketone, and also non-polar O-oxylene, which is the least water soluble actually. So the solubility of O-oxylene in water at ambient temperature is around 170 milligram per liter. Therefore, to achieve a complete dissolution of the solute in water, we prepared the stock solution of the individual solute at a concentration of 100 milligram per liter by weighing a given quantity of chemicals and dissolving it in appropriate volume of deionized and distilled water. After preparing the fly ash through washing and drying, and after preparing the mixtures, 3 bottles from each mixture was mounted in a temperature bath and shaker at 20 centigrade. The isotherm bottles were allowed to equilibrate for 72 hours, and after that we have analyzed it using gas chromatography. So you see in the figure the result of the single solute adsorption isotherm for all the compounds used in this experiment. As the total surface area available for adsorption of the 2 solute was not more than the available for the adsorption of the oxylene in its pure solution, since this area was shared with less effectively absorbed compounds, the butanol, and this efficient use of the available area resulted. In this figure, we can see that the 2 polar compounds, the butanol and the MIBK, were each adsorbed to a much lesser extent when compared with their relative ability to adsorb at an equilibrium concentration of 30 milligram per liter in the single component test. However, the adsorption capacity of fly ash for oxylene was reduced by 18%, as also you can see, and the ultimate capacity of the total solute concentration of 90 milligram per liter was approximately 31% less than which would be predicted from a summation of the single component data. To conclude, the experimental data were compared with the predicted theoretical value for each of the multi-component system. You can find more details about the correlation in the article, actually correlation between the predicted calculated using the simplified competitive adsorption model and the experimental result. And in conclusion, the fly ash is capable to remove organic compounds from the aqueous solution, and the adsorption capacity of fly ash for one solute is affected by the presence of other solutes actually, and the competition for the available adsorption site increases with the increasing number of solutes. and the non-polar organic compounds was absorbed more effectively in comparison to the polar compounds. And we noticed also significant correlation between the predicted absorption capacity calculated when using the simplified competitive absorption model and the experimental value for the two component system. The model unfortunately couldn't predict the absorption capacity of fly ash for the three component system. In order to improve the accuracy of the model for more than two component system, modification of the model to account for the absorption size and non-ideal competition among the organic solutes are recommended. And thank you for listening, and please, if you have any questions, you can send it to the contacts in the next slide. Thank you.